Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. Now, Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And in this hour, we're going to be talking about discoveries in astronomy that are forcing all high school textbook publishers to rewrite everything. We're talking about the discoveries of twins in outer space. Planets that look very similar to the Earth. And the question is, are we about to receive signals, perhaps, from one of these planets that look just like the planet Earth? With us today is an astronomer, Professor Sarah Seeger of MIT. She's a professor of physics and planetary science at MIT, author of a few books, textbooks, in fact, on the search for a doppelganger in outer space, a twin. Think about that. When you look at the night sky and you see all the stars in the heavens, do you realize that perhaps 20% of those stars, 20% of them, have Earth-like planets going around them? And maybe somebody on one of those planets is looking on the Earth and wondering, is there intelligent life on that speck of dust called the planet Earth? Well, this used to be pure speculation, but now we have the data. Recently it was discovered that Proxima b is, in fact, the closest twin of the Earth in outer space, only 30% bigger than the planet Earth, perhaps, just perhaps, with the liquid ocean, similar to our liquid ocean, which, of course, became the home of the first DNA and the first cells, which gave birth to life on the planet Earth. And then we have an announcement from a Russian observatory announcing that they picked up signals from a star, perhaps 94 light years from the planet Earth, that seem to be intelligent signals. This is freaking out the world of astronomy, but it has now focused the work of astronomers as they zero in on this star. And we'll talk to Sarah Seeger about that because her colleagues are also involved with monitoring emissions from these kinds of stars. And then just last year, we had this astounding announcement that we found a star where star light dimmed not 1% but 20%, meaning that perhaps there's a gigantic starship of some sort orbiting that star. This is incredible. And of course, all of this has to be verified by painstaking experiments. But it really tantalizes those people who think that, yeah, they're out there. Once again, this is Dr. Michio Kaku, and this is Science Fantastic, and we're going to bring on our special guest after the commercial break, Dr. Sarah Seeger of MIT, talking about what's out there, twins of the Earth, signals from, who knows, an advanced civilization in outer space. This is no longer the province of UFO buffs. This is the province of PhD physicists like myself and Dr. Sarah Seeger. So stay tuned as we continue discussion of our incredible universe.
You're listening to Science Fantastic.
Well, I've wrestled with reality for 35 years, Doctor, and I'm happy to state I finally won out over it.
With Professor Michio Kaku. This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're going to talk about some of the revolutionary developments taking place in astronomy. We have with us today Professor Sarah Seeger of MIT, Professor of Physics and Planetary Science. And we're going to talk about exoplanets. You know, recently astronomers hit the jackpot. The holy grail for people that are looking in outer space for exoplanets is to find the closest possible, twin of the Earth in outer space. And scientists announced that, they think they have a candidate, and you can't get much closer than 4.2 light years from the planet Earth. And so we'll also talk about the Starshot program. We mentioned it in a previous Science Fantastic program about Stephen Hawking et al.'s idea of sending a chip the size of a postage stamp to the nearby stars. And now we have a target, Proxima b. And then the Internet is buzzing with the news that something or other, maybe a radio signal, is emanating from a planet perhaps 90 or so light years from the planet Earth. And people are saying, aha, is that a signal from intelligent life, or is that just noise in the fluctuation? Well, once again, with us today is Dr. Sarah Seeger. We should mention that she got her bachelor's degree in mathematics and physics from the University of Toronto, went on to get a PhD from Harvard University, my old alma mater. And she's also affiliated with the Institute for Advanced Study at Princeton, where also I was on sabbatical once. And if you want to follow her work, go to her website, Seeger, S-E-A-G-E-R, Seeger Exoplanets, one word, .mit.edu. So, Sarah, glad you could be on Science Fantastic. Okay, the first question we always ask our guests, including Nobel Prize winners, directors of major laboratories, we ask everybody this question. How did you as a youth first get interested in science?
Well, I think many people share this story, but as a young child, I remember seeing the moon, the full moon, and I remember it wouldn't stop following me. No matter where I went, if I was in the car with my dad or walking down the street or turning a corner, it was always there, and I just couldn't understand why. Later on, I remember being on a camping trip and stepping outside my tent at night, and I looked up and I saw so many stars. Wow, I never knew that existed, the mysterious night sky. And I looked up there and I just couldn't help but wonder, like, how did this happen? How did this come to be? And what is out there? And later on I joined an astronomy club as a teenager, and eventually I was lucky enough to stumble into undergraduate education where I could do an internship in astronomy.
Okay. And we should also point out that some UFO buffs believe that when Venus also seems to follow you when you are in a car, people confuse that, therefore, with a flying saucer. Actually, it's just nothing but the planet Venus. So then how did you get interested in becoming a professor of physics and planetary science, looking for exoplanets in outer space? What steered you in that direction?
Well, I'll tell you what, Michio, one thing is that when I was in high school and first learned about physics, I was fascinated by the concept that you can write an equation to describe things. And in high school, we had an experiment where we got a spring and we had to measure the force constant of the spring, like how stiff the spring is. And we had to calculate what angle we had to fire off the spring just with our hands so that it could go through a cardboard and a big hole that the physics teacher was holding. And I worked this out like we just had to follow a formula, basically. And guess what? Mine went through the hole. And I just was so amazed that you could write an equation down and follow it. So I thought, in this sort of naive teenager fashion, that every single thing on our Earth, on our planet, in our universe could be described with equations. And I decided to go into physics.
Yeah, well, that's what I do for a living. Trying to find
when I went
these
into
equations.
I know you do this as well. I learned that approximations are rampant. And although you start kind of ideally writing down an equation and then you derive it in its full glory, you have to get rid of so many terms because the world isn't that simple. And then I was really discouraged, actually. So ultimately, I decided to stick with my true love, astronomy, which is applied physics in the work that I do. And that's how I kind of got there.
Okay. Well, I remember when I was in high school, we learned that there were 9 planets from Mercury, Venus, Earth, Mars, all the way out to Pluto. Now, of course, Pluto is unceremoniously deleted from our solar system of planets. However, now we have up to 4,000 candidate exoplanets. 4,000. You can't memorize all of them in high school. So tell us now, how do we find these exoplanets, given the fact they're so far and they're so dim compared to the mother star? How do we find these things?
Well, Michio, we have 5 ways or more to find exoplanets, but there are 2 ways that are the most successful so far. And one of those is, we call it transits. When a planet goes in front of its star or transits its star, we see a tiny drop in brightness, way too small to see if you're just looking up at a star. But for some planets, it's as high as 1%. So astronomers can monitor the brightness of a star as a function of time, just with their telescopes, taking image after image. And for some of them, when the planet goes in front of the star for, let's say, an hour or a few hours, the starlight drops by 1%, or for a planet the size of Earth, it's way smaller. It's more like a part in 10,000. And then when the planet finishes transiting, the star returns to its normal level of brightness. And that's one of the most popular techniques today. And I just want you to know that if anyone listening is more interested in this, you can go to Zooniverse And you can actually look for planets by eye this way, actually. It kind of guides you through how to do citizen science to help find planets with the transit technique.
And how do you spell that?
Zooniverse, so it's Zooniverse. And if you kind of follow the instructions to Planet Hunters, you actually can see what I'm talking about, and it gives you data from the Kepler Space Telescope that you can help identify transits. Because sometimes, our eye, we do all of this computationally in a very big data analytic fashion, but sometimes the human eye is the best thing.
Okay. Well, I'm just dying to ask you a question about, you mentioned the fact that when a planet moves in front of the mother star, starlight can dim up to like 1%. However, there was this anomaly, this bizarre incident that happened several months ago where starlight dropped, 15-20%, and it happened not just once but twice. And astronomers were sent back to the blackboard scratching their heads, wondering what could possibly create a shadow that dims starlight by 15 to 20%. Is it an extraterrestrial? Is it a comet storm? Do you have any thoughts about this anomaly?
Well, I'd say it's the one thought I want to emphasize is just how great observational science is for discovery. And in the case of Kepler, you have to understand it was looking at hundreds and hundreds of thousands of stars. And so astronomers are just so shocked at this one because what could it be? I don't know what this one is actually. I think people have gone through each scenario trying to rule out various things. I think a kind of swarm of comets or some kind of debris from planets that might have banged into each other or leftover material that's from a collision that's still passing by. I think that's probably the most likely explanation. But in time, hopefully, we'll figure out what it really is. I know that people went wild thanks to a first author paper in the refereed literature that it could be some kind of alien megastructure. But we have a long way to go before we rule out all more natural physical causes.
Okay. So hold your horses out there for those people who think that we have evidence of extraterrestrials in outer space.
I just wanted to review one more thing, and that is the second way that's the most successful so far in finding planets. And this one has a really unfortunate name, actually. It's very technical. We call it the radial velocity method, or sometimes it's just called the wobble technique. And in this case, I want you to imagine there's a star out there with a planet orbiting it, but we can't see the planet. But because that planet and star are orbiting their common center of mass, or you can think of it like the gravitational effect of the planet on the star makes the star wobble. And this is kind of the oldest, most historic way to find planets. We don't see the planet, but because the star moves in a very specific periodic way, we infer the presence of a planet. And that's how the latest news of the latest best planet discovered, Proxima Centauri b, was discovered by the radial velocity technique.
Yeah, we'll talk about that in a minute, but let's wind up on the Kepler satellite, which of course is a game changer in astronomy, forcing every single high school textbook on the planet Earth to have to be rewritten. How does the Kepler satellite work? And it has given us, for the first time in history, a census, a rough census of what's out there in the Milky Way galaxy. This is astounding. Could you elaborate a little bit about the Kepler satellite?
I can. Kepler, we call it the Kepler telescope or the Kepler Space Telescope. Actually, just one thing, it's not actually a satellite orbiting Earth, believe it or not. Kepler orbits the sun, just like Earth does. It's in what we call an Earth trailing orbit. So our Earth is orbiting the sun. The Kepler spacecraft is also orbiting the sun and in an orbit that's slowly drifting away from Earth. And why that's so important is our Earth actually is terrible for astronomy. A satellite orbiting Earth, even like the Hubble Space Telescope, Earth is bright, it's hot, and we want to do precision science far away from Earth. So Kepler is in a very dark place, very far from Earth, and it looks up at the night sky. And for 4 years of its prime mission, it actually looked at one patch of the sky for 4 whole years, staring at those stars. The PI had once called it, jokingly so, like the most boring telescope ever, because all it did was every 6 seconds take the same image of the same part of the sky. And that data gets binned together on board, and individual stars of interest, pixels surrounding them, every few months were downlinked to Earth, and hundreds of thousands of stars were monitored. And looking at them, just looking at the star's brightness as a function of time, and astronomers all around the globe have downloaded the data to search for transiting planets going in front of their star. And by being way more sensitive, like 100 times or more sensitive than anything that came before it, and by being able to stare at the same stars for so long, Kepler uncovered planets and planetary systems beyond anything we had imagined.
Right. And let's talk about a rough census of the Milky Way galaxy. Of course, we haven't scanned the entire Milky Way galaxy. We've only scanned a piece of it. But we can infer the number of stars which have planets going around them and the percent of stars that have Earth-like planets going around them. So what have we found? On average, of the stars in the heavens that you see at night, what percent have planets going around them, maybe Jupiter-sized planets, and what percent of them in turn may have Earth-like planets?
Well, let's start with the Earth case, and then we can back up.
Okay.
Okay, so it turns out this is a very hard question to give you an exact answer on. I would say that the answer that was kind of given publicly to the most fanfare was something like as many as 1 in 5 stars like our sun could have a planet size of the Earth in an Earth-like orbit. That might sound a bit overly scientific for you, because we don't know if a planet is Earth-like. It really depends on the greenhouse gases in its atmosphere. But to answer your question, let's say as many as 1 in 5 stars like our sun could have an Earth.
So if the Milky Way galaxy has 100 billion stars, then we're talking about potentially billions of Earth-like planets right in our solar system, right?
Right. I mean, right. We could have more than tens of billions of Earth-like planets, possibly.
So isn't this a game changer? I mean, we had the skeptics who were saying, bah, humbug. I mean, how many planets are there going to be in the Milky Way galaxy? But now we have a first order estimate, and the estimate comes in the billions. This is astounding, isn't it?
It is astounding. And together with Kepler and other planet-finding techniques and telescopes, we actually have evidence that almost all stars should have planetary systems.
So you're saying that when you look in the night sky at night, tonight, you go outside, look up, you're saying that on average it could be that every single star, on average, has some kind of planetary system. Is that what you're saying?
That's what I'm saying. And I'm saying to you, Michio, the next time you go out, I don't know how many stars you can see from New York City, but
Not
when
many.
you go out there and look up, you can even wonder if there's a planet around that star, and if maybe there are creatures around that planet looking out at our sun amidst all of their stars, wondering the same thing.
Yeah, they're wondering if there's intelligent life on the Earth. Well, obviously the answer to that is no. Obviously there's no intelligent life on this planet. Okay, well, now let's talk about the big discovery where the press is saying that we have a doppelganger out there in outer space that is a planet orbiting the closest star, which may have Earth-like conditions. But could you elaborate? What was this astounding discovery?
Well, the astounding discovery that was announced very recently is that there's a planet about the mass of Earth orbiting our very nearest star, Proxima Centauri. Now, Proxima Centauri is not a star like our sun. It's actually much smaller and dimmer and redder. And this planet has an orbit of about 11 days. It takes 11 days to go around its star, our own Earth. Of course, our year it takes us 365 and a bit days to go around our sun. But the star has lower luminosity output, so the planet is quite close. Now, those things are really all we know about the planet right now. But just the fact that there is a planet about Earth mass that's about the right distance from the star to have the right surface temperature for life, that's the big news.
Well, let's take a short commercial break. And after the break, we're going to talk about, well, what are we going to find if one day we send the first starships to the nearest planet to the Earth. And that could happen perhaps in a few decades. We're not talking centuries now. And we'll talk about that, the Starshot program, after the break. Once again, you are listening to Science Fantastic with Professor Michio Kaku.
Does he know about string theory? He wrote the book on it. This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're talking about incredible discoveries that are forcing high school textbooks to rewrite the history of the universe. We're talking about the discovery of, perhaps, a twin in outer space of the planet Earth. We're talking about the potential of one day, perhaps in a few decades, not centuries, sending the first starship to one of these planets in outer space, and a signal. A signal has recently been detected that some people claim may just possibly be evidence of an extraterrestrial advanced civilization in outer space. With us today is Professor Sarah Seeger of MIT. Her website is Seeger Exoplanets, one word, SeegerExoplanets.MIT.edu. And before we continue, let's just make a short announcement. I'm always on a book tour someplace or other. If you want to find out my schedule, go to mkaku.org, mkaku.org, or my Facebook site. We have 3 million fans on my Facebook site, or my Twitter account. We have 500,000 people taking Twitter. And I'll be talking about one of my best-selling books. I have 3 New York Times bestsellers, Physics of the Impossible, talking about the physics of antimatter, time travel, teleportation, invisibility, and also Physics of the Future, another New York Times bestseller, talking about artificial intelligence, talking about how we will live in the next 50 to 100 years. And my last book is called The Future of the Mind. Did you know that in the physics laboratories, we can duplicate many of the feats of science fiction? Telepathy, telekinesis, uploading memories, downloading memories, exoskeletons like Iron Man, all of the above have been accomplished because of modern physics. So find out by just going to my website. Well, once again, with us today is Dr. Sarah Seeger. She got her PhD in astronomy from Harvard University. And we are talking about exoplanets. The whole scientific universe is abuzz with the news that we found a twin. Well, we don't exactly know what's on that twin, but we found an object that's perhaps 30% bigger than the planet Earth. We don't know for sure, but it looks very close to the characteristics of the Earth. Now, Sarah, do we know anything about its atmosphere or whether or not it has water on it?
Right now we don't. All we know is the planet's approximate mass, which is about 30% more massive than Earth, and we know that its orbit is very favorable when we want to speculate about whether or not the planet could be the right temperature for life. The reason we don't know more about it is because the planet was found indirectly. And we hope that in the future we will be able to observe this planet with large ground-based telescopes that are under construction right now, but they won't be finished for many years. And with those new telescopes, we hope that we can look at the atmosphere and see water vapor in the atmosphere or other things.
Okay, well, my colleague Stephen Hawking has, with billionaires, announced an ambitious program to send the first Starship to the nearby stars. And, of course, Proxima b is way up on the list of targets. And I understand that you are also associated with the Starshot program. Could you explain how do we build a Starship?
Well, the Starshot concept actually is quite different from things that we're used to when we watch movies or read books on science fiction. This concept is instead of sending one big ship that humans could go on, or even just a couple of people, to send 1,000 little tiny spacecraft. Actually, they want to call them star chips because these items would be just centimeters in size and just a few grams in their mass. And the goal is to launch a mothership carrying about 1,000 of these tiny spacecraft and then to deploy them once it gets to space. And the concept further imagines ground-based lasers would focus a light beam on these spacecraft and accelerate them so they can travel faster than anything we've ever imagined and send them on their way to Proxima Centauri. And with 1,000 of them, the thought is that if many of them get destroyed by bumping into cosmic dust particles or some other reason, that some of them will survive long enough to reach Proxima Centauri and to snap an image and send that image back to us here on Earth.
Now, I understand that the weak link in all of this is the lasers. You have to have, 800 megawatts of laser power, 800 gigawatts of laser power, and a nuclear power plant only has 1 gigawatt worth of energy output. And the aiming must be incredibly precise, right? Oh, okay. We have to take a short commercial break, but after the break, we're going to continue the discussion of Starshot. What would it be like to send the first Starship to a nearby planet? This is a real game changer. It could change human history for all we know.
You're listening to Science Fantastic. listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're talking about the possibility of one day sending the first Starship to a nearby planet. And of course, the world of astronomy is all abuzz with the news that Proxima b could be our doppelganger in outer space. It's the nearest planet to the Earth that we have discovered so far, orbiting around the Alpha Centauri system, which is a triple star system. And with us today to talk about all these incredible discoveries is Dr. Sarah Seeger, Professor of Physics and Planetary Science at MIT. And you can go to her website, seegerexoplanets.mit.edu. And we're not talking about sending the Enterprise, a gigantic starship, to Proxima b. We're talking about sending maybe an object the size of a postage stamp, a chip, thousands of them, into outer space, hoping that a few of them may actually reach the nearby star systems. And by chance, it turns out that just a few days ago, I actually met with William Shatner, who was, of course, the captain of the Star Trek series. We were doing a TV series that he's hosting about astronomy. And I mentioned to William Shatner that, yes, the first Starship may not be the Enterprise. The first Starship may be one of these little postage stamp chips. And he mentioned the fact that, in a few weeks, he'll actually be meeting Stephen Hawking personally for the TV series, and he'll ask him that question about the starships. So, Sarah, let's break it down. We're not talking about the Enterprise. We're talking about lasers shooting some kind of sail to Proxima b. Could you elaborate?
Sure. Well, these little tiny star chips, as they're being called, would go to space, and they actually would have to, each one of them, deploy a sail. And that sail would be accelerated not by wind, but by a light beam. And we would have to figure out how to build telescopes, lots of them on the ground, not to receive light, but to focus a laser beam and send it out precisely to hit these sails. And on the ground, we'd be thinking about something like a square kilometer devoted to telescopes like this. And we'd have to correct for the blurring effects of Earth's atmosphere to get this light focused well enough. And it would really be tons of energy, like 100 gigawatts. You have to imagine like the amount of energy as if it were like billions of light bulbs. And so this actually is a challenge.
And aiming it, isn't that also going to be a problem? Also given the fact that light is a wave, it also obeys, Heisenberg uncertainty, and the aiming must be incredibly precise in order to shoot this to Alpha Centauri, right? What are your thoughts?
Well, they only have to aim it at the beginning to hit the sails to accelerate them. Once these sails are accelerated, you're done with your lasers, actually. You're done with them. And then hopefully we can use them for other things like astronomy. But you really only have to do it once. And even though that is very difficult, it's probably not the biggest challenge of Starshot. I think we can figure out how to focus the light and aim it to something that's not too far from Earth.
Okay, well, let's take another short commercial break. Once again, you are listening to Science Fantastic with Professor Michio Kaku. Our special guest today is Dr. Sarah Seeger, Professor of Physics and Planetary Science at MIT, and we are talking about exoplanets, twins, quote-unquote, of the planet Earth in outer space. And what would it take to one day visit one of these? So let's take a short commercial break, and after that, we're going to talk about intelligent life in outer space. Is anyone looking back at us from outer space as we look into deep space, searching for Earth-like planets?
Come on, you know you want to. Call and ask. Professor Kaku has the answer. And on the off chance he doesn't, one of his friends will. This is Science Fantastic. You're listening to Science Fantastic with Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're talking about revolutionary discoveries being made, even as we speak, about this great universe of ours. You know, sometimes we spend so much of our time looking down on the pavement, and we don't look up. And when you look up, you realize there's a whole universe out there waiting to be discovered. And you realize that discoveries are being made every few months. And the recent discovery that has the world of astronomy abuzz is that, we hit the jackpot. the closest exoplanet to the planet Earth, circulating a star only 4.2 light years away. You realize that when you look at the night sky, stars are, well, a few hundred, maybe a few thousand light years away. This star is a hop, skip, and a jump away from us, only 4.2 light years. And one day, we may use laser beams to send sails at perhaps 20% of the speed of light. Now, Sarah, some people have said that this system being pushed by Stephen Hawking and a group of billionaires, some people say that it could also be used to shoot probes to Mars or Venus. Why do we have to wait a year to go to Mars when we can do it in one day, traveling at 20% the speed of light? So perhaps one day we'll have an interplanetary network shooting chips using laser beams right across the solar system. What are your thoughts?
I think that would be amazing. And I've also heard those comments for the people who think Starshot might just be a bit too ambitious for humans with today's technology, that even if they don't reach that original planet, it will be just phenomenal to be able to, yes, send these star chips all around our solar system in no time. Remember, New Horizons that reached Pluto not too long ago took 10 years. So imagine if we could go to Pluto, see something interesting, and then send something else to get there in a few days.
Yeah, and traveling at 20% the speed of light, you're talking about going to Mars in a matter of minutes, rather than 9 months to go to Mars, a matter of minutes. A day.
One thing we haven't mentioned yet is that these things don't have a way to slow down right now. So for the moment, you're talking about a little star chip zipping past Mars at 20% the speed of light and just snapping a photo and sending the image back to Earth, not landing, not being able to slow down.
Right. But it's an ambitious program, and I understand that $100 million has already been pledged by people of the likes of Mark Zuckerberg of Facebook and other billionaires to jumpstart the research on such a program. Absolutely incredible. Now, let's switch gears a little bit, and another bit of news. There is a rumor that is being spread by the newspapers saying that a Russian telescope has picked up some kind of radio signal, a very powerful signal, from what might be, with a capital M, what might be an intelligent civilization in outer space. Well, what are your thoughts? What do astronomers think about this? Not just people who follow this kind of stuff and UFO buffs, but, what does the astronomical community think about this?
Well, Michio, you're a physicist as well, and you know that our job in training is to be skeptical. So I would say that most people in the community are skeptical. And there is a reason, though, because what we want to do is confirm or deny the signal. But we don't. The people who, first of all, let's back up a little. It's a star. The signal's coming from the direction of the star, a star like our sun, and it just has a catalog name, HD 164595. It's about 100 light years away. And this particular star system actually has a confirmed planet around it. The planet's about 16 times Earth's mass, and it has about a 40-day period. So the radio telescope that observes stars like that, they can't observe that star specifically. They're kind of looking in the general area, a kind of bigger patch on the sky, but they do see a signal. And that signal, they talked about at a conference recently, and that's what made the news. Now, this signal dates back, actually, it came from May 2015. And they saw the signal one time, although they had looked about almost 40 different times. So we hope that if there are intelligent aliens out there on a planet around a nearby star, that they're going to send us a signal more than once. Like, remember the movie Contact? How in Contact there's a signal, and later on it comes again, and then again and again. But if it just comes one time, we don't have a way to confirm or deny it. And some of my astronomy colleagues have actually already, gone back and looked at that same star. They've done calculations to show whether or not it's likely to be just a transient or some noise. And the answer is we just don't know.
Okay, now science is based on what is reproducible, testable, and falsifiable. Now, if you get one signal from something out there, it's not reproducible, right? I mean, you can't test it against any other parameters. It's just a piece of noise out there. So it's just premature, then, you're saying, to say.
It's premature in that sense. And according to my friends who do work in SETI, the best thing is, if you find a signal like this, is to tell people immediately so that they can look up right away as well, in case the aliens are out there and send you a signal, and they're going to send you one tomorrow, not a year later. But actually, astronomers can do something more complicated. And remember, I told you that we're kind of trained to be skeptical. they can go back and look at archival data, because thanks to computers now, a lot of data is just stored. So they can go look back and they can see how often, you see a signal like this elsewhere in the sky. They can look at the specs of the actual instrument that was used. And, you can actually go back and try to work your way through how likely it is to be a real signal or not. And so that type of work is ongoing.
Okay. Well, also on the air, several times we've had Dr. Seth Shostak, PhD physicist from Princeton, and he's one of the directors of the SETI project. And he claimed on radio that in the next 20 years or so, they will find this signal, a reproducible, testable, falsifiable signal from an intelligent civilization in outer space. Well, first of all, do you share his optimism?
Well, funnily enough, Michio, I share his optimism for my own field because the reason we're all here working so hard and getting up every morning really early to get our work done is because we have optimism about what we're doing. So I don't blame him for his optimism, but I don't necessarily share it.
Okay. Well, unfortunately, we've run out of time. Once again, our special guest today has been Dr. Sarah Seeger. If you want to find out more about her work, go to mit.edu. It's Seeger Exoplanets, one word, SEAGER, exoplanets.mit.edu.
The most up-to-date announcements and analysis from today's technological leaders every week on Science Fantastic. Now, Science Fantastic with Professor Michio Kaku.
This is Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. And in this hour, once again, we're going to throw the lines open because this hour is your hour. This is not the time when I pontificate about what's happening in the universe. No, you can get to the telephones and you can give me feedback. You can ask a question. You can make a comment on national radio. Give us a call. The hotline number is 866-323-2129. Write this number down, 866-323-2129. And remember, no question is, quote, too dumb or too stupid to put on national radio. And if your kids ask you a question at dinner time, why not put them on radio? Why not give them the telephone and have them call 866-323-2129 and have them ask that homework question on over 100 radio stations that carry Science Fantastic. And so once again, no question is too dumb or too stupid. After all, it was a 16-year-old boy. A 16-year-old boy who asked a stupid question, can you outrace a light beam? Well, it took him 10 years to figure it out from the years 16 to 26. But when he was 26 years old, he published the answer. And that answer is now known as relativity. And that 16-year-old boy was called Albert Einstein. And so sometimes the dumbest questions are the most profound. In fact, years ago, a few hundred years ago, there was a 23-year-old gentleman who asked an even stupider question. And that is, does the moon fall? If an apple falls, does the moon also fall? Well, when he was 23 years old, he found the answer to that question. His name was Sir Isaac Newton. And when he found out that, yes, the moon is in free fall, the moon is falling continually, doesn't hit the Earth, of course, because the Earth bends beneath it, but he wrote down the mechanics of the solar system. Our space program, the entire space program of the United States and Russia, is dedicated to solving solutions of Newton's laws of gravity for our space probes. And when we send the first astronauts to Mars, you can bet that all the equations guiding our space probe comes from the work of this 23-year-old gentleman who asked himself a question, if an apple falls, does the moon also fall? So give us a call. The hotline number is 866-323-2129. All we ask is that you leave your name, call letters of the radio station and the city you're calling from, and perhaps you can be heard on over 100 radio stations that carry Science Fantastic. Also, let me say that I'm always touring the country, giving lectures. Go to my website, mkaku.org, mkaku.org, or go to my Facebook site. We have 3 million fans on Facebook, or get a Twitter feed. We have 500,000 people picking up our Twitter feed. And find out about my latest books. I have 3 New York Times bestsellers. The first was The Physics of the Impossible, talking about time travel, starships, teleportation. The next New York Times bestseller was Physics of the Future, talking about robots, artificial intelligence, how we will live, what medicine will look like in the next 50 to 100 years. And then my latest book is The Future of the Mind, how we physicists are teasing apart the secrets of the living brain, telepathy, telekinesis, mind reading, mind over matter, exoskeletons, Iron Man costumes, all of that being worked out not by comic book writers, but by physicists like myself. Find out more by going to my website, mkaku.org. Okay, well, let's throw the lines open. Once again, this hour is your hour. This is the time when you can call 866-323-2129. Ask a question or make a comment about science. So let's take the next listener phone call.
Hi, this is Eric from Fairbanks, Alaska, listening on 970 KFBX. I was just wondering, as we progress from a Type 0 civilization and we crawl out of the mud to a Type 1 civilization, will we still elect a leader? Will there still be a need for like a centralized system of governments? Or will we all just kind of like work together and know what to do, sort of like ants in a hive as, we progress into a like a planetary society? Will we need to elect a fearless leader on a white horse and a king on a throne to, make proclamations and issue orders? Or will we all just kind of like, I guess, know what to do and just govern ourselves, and as if we're all working towards that, collective goal? Will there be a need for leaders, I suppose, and leadership in the future? Thank you.
Well, you ask a question that's been bothering me for several decades. When I was a child, I read Isaac Asimov's Foundation trilogy. I highly recommend it. In fact, it is sometimes called the greatest science fiction novel ever written, by Isaac Asimov, the Foundation trilogy. It blew me away when I was, in junior high school, reading the Foundation trilogy. It talks about the galaxy 50,000 years from now, where we'll have galactic starships, a galactic civilization. But then I said to myself, come on, there's something wrong. There's something wrong with the Foundation series because the people of the future, 50,000 years from now, they act just like us. They have jealousies. They have kings, queens. They have emperors. They have proclamations. They have fearless leaders. They have propaganda. And I said to myself, surely an advanced civilization 50,000 years from now, they're not going to have the stupid kinds of fearless leaders on a white horse that we have. Well, now I'm older, and now I realize that perhaps Isaac Asimov had some wisdom there. Because, you see, we haven't changed genetically for the past 100,000 years since we first emerged from Africa. So you take one of our ancestors 100,000 years ago, give him a shave, put him in a 3-piece suit, put him on Wall Street, and they'll look like all the other barbarians on Wall Street. Indistinguishable, with the same kind of selfishness, the same kind of greed, the same kinds of vision, the same kinds of compassion, all of that. The whole spectrum of human behavior manifested in a caveman or a cavewoman who lived 100,000 years ago. So I think that, as we progress into the future, unless we genetically change our personality, we will still have elections, we'll still have debates, we'll still have, some leaders on a white horse. We'll still have all of that unless we change human behavior, and I don't see that happening anytime soon. Also, you mentioned Type 0 to Type 1, so let me clarify that really quick. We physicists catalog civilizations by energy. We don't talk about little green men in outer space riding flying saucers. No. We talk about type 1, type 2, type 3. A type 1 civilization that you mentioned is maybe 100 years into the future. They are planetary. They control all planetary energy. They can, for example, control the weather. They can influence the outcome of volcanoes. They have cities on the ocean. Anything planetary they control. Type 2 is stellar. They can manipulate an entire star, like Star Trek. The Federation of Planets would be a typical type 2 civilization. And then type 3 would be galactic, like in Star Wars, where a civilization that roams the galactic space lanes. So even though technology will be incredibly advanced because technology and energy grow exponentially in the main, it does not mean that human behavior will also grow exponentially. Now, in Star Trek, we also have the Borg. They are like ants. They communicate with each other telepathically. And yeah, we may have something like that. The future of the Internet, I think, is going to be called BrainNet. Already, we can record the first simple memories and record them and play them back and upload these memories into animals like mice. Eventually, we'll do it with chimpanzees and primates. The point here is that, yeah, we'll have something like a BrainNet, whereby people will mentally communicate with each other. But does that mean that we're going to have pure democracy with everyone agreeing on everything? No. We'll still have the same stupidity, selfishness. All that is not going to change anytime soon. So even though our technology will be exponentially more advanced than ours, we'll still have a lot of the jealousies. The benefit, however, of being type 1 is that we'll have many, many decades to work out all our sectarian, religious, racial problems. We are very young as a civilization. We just came out of the swamp just 100, 200 years ago when we had the Industrial Revolution. So we're still very young as a civilization. And I would think that by the time we hit type 1 as a planetary civilization, we'll have many a decade to work out all sorts of planetary problems democratically. Yes.
Here is Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. Once again, this is your hour. This is when you can shine by calling 866-323-2129. So give us a call. All we ask is that you leave your name, call letters to the radio station, and the city you're calling from. And perhaps your thoughts will be heard on over 100 radio stations that carry Science Fantastic. Okay, well, let's take the next listener phone call.
Yes, Professor. My name is Chuck, and I'm calling from Daytona Beach. Do you see the science of solving the telomere being worn out and being able to preserve the telomere, and if in the next 10 years, and if so, what would be the repercussions of society, and what exactly would a person be like if the telomere never showed any aging? Thank you.
Well, you ask a very important question. First of all, let's define a few terms. Telomeres are, in some sense, the biological clock of a cell that tells the cell when to die. It turns out that at the ends of the chromosome, there is a tip that holds the chromosome intact. Think of your shoelace. At the end of your shoelace is a plastic tip. That's called the telomere. Every time the cell divides, it gets older, and the telomeres get shorter. After 60 or so reproductions, the telomeres are so short, they disappear, and the chromosome frays just like your shoelace. If the tips of your shoelace fray, then the whole shoelace starts to come apart. At that point, the cell goes into senescence. That is, it gets slower and slower, more and more sluggish, until it eventually dies. This is called the Hayflick limit. The Hayflick limit is 60 reproductions or so. Now, I've interviewed Professor Hayflick, and I've also interviewed people who think that this could be the fountain of youth. So let's talk about the controversy. It turns out that, yes, you can, quote, immortalize a cell by hitting it with telomerase. Telomerase is an enzyme that prevents the telomeres from getting shorter. So your clock, in some sense, is stopped. You are stopping the clock. I had one doctor on the air who said that he can, quote, immortalize human skin cells. You put them in a petri dish, you hit them with the enzyme telomerase, and they just keep dividing forever. Not just 60 times. They've divided thousands of times. They are, in some sense, immortal. Now, what's the catch? Well, there's always a catch. It turns out that cancer cells also use telomerase. Cancer cells, in some sense, are not stupid. They know that they have telomeres. They get shorter. So why don't they stop the clock? And they can simply divide forever. And, of course, that's what cancer is. What is cancer? Cancer is a normal cell that simply divides forever until it kills you, until it forms a tumor that chokes you and your organs die as a consequence. So, in other words, telomerase is not the fountain of youth. However, it could be part of it. One day, we may actually have a fountain of youth. It could be a combination of several different kinds of approaches. Genetic engineering, we're locating the genes which control the aging process, not to mention enzymes like resveratrol and the sirtuin genes, and of course, there's something called caloric restrictions. You eat 30% less, you live 30% longer. And also telomerase, that stops the biological clock. So in the future, I think that a combination of these therapies may give us a handle on the fountain of youth. But it's way too early to say. In fact, the only thing which has worked every single time so far, the only thing which has worked every single time is caloric restriction. You eat 30% less, you live 30% longer. And then the caller asked a question, well, let's say that we do get the fountain of youth. What would that mean for society? Will all hell break loose? Well, yes and no. First of all, let's take a look at Japan and Europe, specifically Austria, Switzerland, Germany. We have a problem there. They are living longer and longer. In fact, Japanese women have the world's record for longevity. They are the longest lived ethnic group on the planet Earth, Japanese women. And then the question is, what has it done for society? Is it good or bad? Well, some people think it's not so good because Japan is aging rapidly. Not too many young people are being born, and there's very little immigration coming into Japan. And that means that Japan is a train wreck in slow motion, to be followed by Europe. Japan is shrinking at the present time. It's official. In the last 2 or 3 years, you can see that the birth rate and the death rate in Japan flipped. It means lots of old people, no young people being born. So instead of overpopulation, which is the point I'm driving at, instead of overpopulation, we may have underpopulation. We may have a race of old people that simply don't want to be bothered to have kids anymore. They got that out of the way a few centuries ago. And they simply want to lead a life as an old person forever. So there are all sorts of different kinds of sociological problems once we have something called the fountain of youth. But to summarize, don't believe any of the hype if someone claims that they have found the fountain of youth. That's a bunch of junk. However, I don't rule it out. I think that at some point in the future, scientists will use a combination of genetic engineering, certain enzymes like resveratrol and the sirtuin genes, caloric restriction of some sort, and telomerase to give us longer life. This is well within the realm of scientific possibility.
You're listening to Science Fantastic with Professor Michio Kaku.
back to Science Fantastic with Professor Michio Kaku. Once again, in this hour, we throw the lines open because this hour is your hour. This is the time when you can get to the telephones and have your thoughts heard on national radio. All you have to do is give us a call at 866-323-2129. Okay, well, moving right along, let's take the next listener phone call.
So I've got a question about dark matter. So you say when you create it, it just falls through things. How would we know that we haven't already made it and it's just oscillating back and forth between Geneva, Switzerland, and Wellington, New Zealand this whole time? How do you not? How can we be sure? Thank you.
Well, you ask an interesting scientific question. Can dark matter be oscillating right at this moment from between New York City as it plunges into the Earth, goes right to the core of the Earth and goes all the way to China, reverses direction in China, and comes back to New York City? Is that possible? Yes. That is well within the realm of physical possibility. So let's back up a few steps. First of all, what is dark matter? Well, we don't know, but it surrounds the galaxy. In fact, we have maps of dark matter throughout the universe. And how much of dark matter is there? Maybe 10 times more dark matter than ordinary matter. But you might say to yourself, well, I took high school astronomy, and in high school astronomy, they told us that the Earth and the heavens are basically made out of atoms. Wrong. All the high school textbooks are now being rewritten. We now realize that most of the matter of the universe is invisible. Dark matter. That's why we didn't pick it up before. Our telescopes cannot see invisible matter. And because it is invisible, and because it has no interactions with electromagnetic force fields, like electric fields and magnetic fields, it goes right through you. In fact, if I have a bunch of neutrons, the same thing would happen. If I have a collection of neutrons, they're also neutral, they have no charge, and I had in my hand a bunch of neutrons, they would simply filter right through the sinews and bone and blood of my hands, go right through the floor, go right through the center of the Earth, and go all the way to China, reverse direction, and come back. Ordinary neutrons can do this, and dark matter is even stranger than ordinary neutrons. And so could that happen? That dark matter could be here right in your room, oscillating between your room in China? And the answer is yes. Unfortunately, it's very difficult to detect. We are moving in a wind of dark matter. And because it is so rare, and because it goes right through you, and because it's invisible, you would not even know it. You would not even know that your body is moving through a wind of dark matter as the Earth goes around the sun. I should also point out that just last week, astronomers announced the first discovery of a dark galaxy. This is astounding. When you think of a galaxy, you think of this bright spiral consisting of 100 billion stars. Well, now we know that there are galaxies made out of dark matter that are more or less invisible. How do we know they're there? Well, we picked up this fuzz, this gigantic fuzz that seems to be spiraling, and sure enough, it bends light using gravitation. So the universe turned out to be a lot stranger than we originally expected. And what is dark matter? Well, if you know what dark matter is, tell me first. Now, we can split the Nobel Prize cash money, you and me. We don't know what dark matter is, but the leading candidate is the next vibrational octave of the string. We are the lowest octave. Everything you see around you is a particle that represents vibrations of the lowest excitations of a tiny vibrating string. The next set of vibrations would be invisible. You can calculate that. And yes, we think that is dark matter.
You're listening to Science Fantastic with Professor Michio Kaku. Here is Professor Michio Kaku.
Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile some of the most amazing developments in science. And if you want to be part of Science Fantastic, why not give us a call? The hotline number for you is 866-323-2129. You're not going to get a busy signal. You'll get a recording asking you for your name, the call letters of the radio station you're calling from, and the city you're calling from, and perhaps your thoughts will be heard on over 100 radio stations that carry Science Fantastic. Maybe one day at the dinner table, your kids ask you a science question that leaves you stumped. Well, you can help with their homework by putting them on the air. Why not have them ask a question that gets on national radio? Okay, well, moving right along now, let's take the next listener phone call.
My question is it possible that a lightning strike could strike through the living room and not burn anything? I can remember as a child, by the way, my name is Darcy, and I will be 40 next month. I'm from Tri-Cities, Washington. I can remember as a child being in the house. There was a big thunderstorm, and I was scared, and a lightning bolt came through the house. And when I said something to somebody, they just laughed at me. Anyway, it's an odd question. Have a good night.
Okay, well, you ask a very interesting question. Now, most high school textbooks would say that lightning bolts only hit the highest object and the sharpest object, because that's where you have a concentration of electric fields. So, for example, the top of a building, like the Empire State Building, for example, that's been hit many times by lightning bolts. So, the high school textbook explanation would say, no, that's not possible because your house is not the highest point and there's no sharp object. But reality, of course, is a lot more complicated than a high school textbook. First of all, you have fluctuations in the electric field, and then you have offshoots. Even though the main blast of electrical energy may have hit the highest point, you have lots of forks, and you have other pathways for electricity to go through. For example, years ago, I had a house where there was a sprinkler system that was electrically controlled, and believe it or not, a lightning bolt hit the house and blew out the electric box which controlled the sprinkler system. Well, I went to the basement, I looked and I saw on the floor this burnt cinder. It was practically steaming still, this burnt cinder of the electric box which controlled the sprinkler system. Now, at first I said to myself, come on, there's no way that a lightning bolt could have done this, because lightning bolts hit the tallest object and the sharpest object, because that's where you have the most concentration of electric fields. In fact, it was Benjamin Franklin. It was Benjamin Franklin who was the first to actually commercialize this idea of lightning rods. But then I realized that, hey, nature sometimes is a lot more sophisticated and a lot more complex than high school textbook explanations. As I said before, you can have oscillations, you can have fluctuations, and you can have offshoots. And that's why many times it occurs that lightning bolts will not necessarily hit the tallest object. Let me give you another example. A few decades ago in New York City, where I am right now, in Central Park, there were a group of kids who were hit by a lightning bolt. Many of them died, and their high school teacher gave them the wrong piece of advice.
Science Fantastic with Professor Michio Kaku. This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, the lines are open. You can give us a call and have your thoughts heard on national radio. The number to call is 866 323-2129. You'll get a recording. All you have to do is leave your name, the call letters of the radio station you're calling from, and the city you're calling from, and perhaps your thoughts will be heard on national radio. Well, before the break, we had a question from somebody who claimed that a lightning bolt went right through the living room window, and is that possible? And the answer is yes, there are anomalies. Yes, there are fluctuations. And yes, there are offshoots of the main lightning bolt that go in all sorts of different directions. It is certainly possible. And I was just saying that years ago, there was a thunderstorm that hit Manhattan. And there was a bunch of students under the guidance of a teacher who took shelter underneath a tree in Central Park. Well, that's not a good idea. But the teacher probably thought that the highest point was the top of the tree, not the bottom of the tree. So it was safe to take these kids to underneath the tree. Well, it made the front page of the newspaper. A lightning bolt did hit. It hit the kids. Several kids died as a consequence, and it was a tragedy. What went wrong? Well, first of all, you do not want to go near a tree, even if the top of the tree is higher than you are, because the tree itself will attract lightning bolts, and you have offshoots and fluctuations, and you can definitely be hit if you are hiding underneath a tree. Also, by the way, some people ask me that if somebody is electrocuted by let's say, a power cable that becomes separated, and all of a sudden somebody touches it and cannot let go because the muscles of your hand contract, what do? Well, don't grab the person to yank them off this live wire, because then you too will be, your muscles will contract, and you too will be electrocuted. What you should do is, for example, take off your jacket, get some insulation, lots of insulation, and then, for example, wrap your jacket around the person's leg, and then yank that person, because, of course, his muscles are contracting over that cable. Once the person is separated and doesn't breathe, it doesn't mean the person is dead. In other words, those children that died in Central Park, in some sense, they were still alive. But the teacher didn't know what to do. What to do is you give them CPR, you give them first aid, because the electrical storm simply stopped their heart and their lungs from firing correctly. But you can jumpstart it. You can start it up again. But unfortunately, the teachers made two mistakes. One, they put the kids underneath a tree in the middle of a lightning storm. And second of all, the kids were not dead. They simply had their heart and perhaps lungs stopped. But you can revive them using CPR. Okay, well, moving right along, let's take the next listener phone call.
Hi, yes, I'm listening to the show right now, and you're talking about the Zika virus. And I wanted to ask you a question. Living in Orlando, Florida, we have a lot of people here with Zika virus, and experts said to avoid the area. I'm even reading the news story on Zika virus map. That's ZikaVirusMap.net, and I use that on a daily basis to find out the outbreak area, because it's expelling so many people here in Florida, and I'm scared to go out of my house. So if you could let me know how soon the Zika virus mosquitoes will be biting people, infecting in Orlando. I'm thinking probably next 6 months, but I have no idea. I'm just scared to go out of my house. So I think I'm listening to your show right now, and hopefully you can give some good advice. Thank you.
Okay, well, the first piece of advice is listen to the authorities. They are giving you practical advice about what to do. For example, use mosquito repellent when you go outside. Cover yourself. Don't go to areas where there's a known infestation of mosquitoes, and so on and so forth. A lot of common sense things. However, let's be real, and that is we are witnessing a science experiment. A science experiment because we really don't know a lot about the virus. For example, how long does it stay in your body? We really don't know because we haven't had that much experience with it. Does it go away after a few months and you don't infect anyone anymore? Or does it stay with you for years and years, in which case you could be potentially infecting scores of people even after the epidemic is over? We don't really know for sure. And so it's a learning experience. But, hey, that's the way science is done. Science is done sometimes through trial and error. And at the present time, as you know, we have no vaccine for it. Of course, scientists are working on it, but we have no way of curing it. And we should also point out that we don't even know where it came from. You realize that many diseases come from the animal kingdom, and they are the reservoirs that keep these viruses alive for thousands of years. And it could be that the Zika virus is very ancient. Ancient, but it never spread because jet planes and modern travel and population explosions didn't take place till recently. So it could even be that the Zika virus is very old, and so many questions that are not yet answered. And right now, even experimental methods are being tried. You can genetically engineer sterile mosquitoes, and they're being released, and with the hope that maybe it'll create sterility among these mosquitoes so they won't be able to reproduce. And so the long and the short of it is, listen to common sense, first aid recommendations, but realize that there's a lot we don't know about the Zika virus, including for how long you can infect other people. And we're still working on a vaccine. We don't have it yet. But of course, we're working on it. And we should expect more of these things as more ancient kinds of diseases, or potentially ancient kinds of diseases, spring forth from the jungle. Because civilization is encroaching upon their territory. Okay, well, unfortunately, that's it for Science Fantastic.